Concrete column analysis and design. L-shape, T-shape or any shape concrete column. Using concrete interaction diagram. This presentation is writing by assuming readers have basic concrete column analysis and design knowledge. Most of colleges offer concrete course and mostly it will cover column compression member material.
Design is a repeated analysis. You have already calculated the load on the element you want to design. You perform an initial design by using some charts, past example or your experience. You then perform the analysis to see the design you had enough capacity to take the design load. If the answer is yes, you complete your design. However, you may want to refine your design by saving some material or improving constructability. After you modify your design, you back to perform analysis again. You repeat those process until you obtain the solution you need.
The concrete column interaction diagrams were published by ACI, PCA, or CRSI since ACI Building Code published. The concrete column interaction diagram for axial compression and bending moment about one axis could be in compression strain controls or tension strain controls. The divided point is balanced strain condition. Concrete interaction diagram. The balanced strain condition defined simultaneous occurrence of strain of 0.003 in the extreme fiber of concrete and the strain of most of outside steel equals Fy divided by Es on the tension steel. The ACI code impose a limit at compression controls region by a maximum axial compression. Also, for very small compression load close to pure flux member, the ACI code said, for compression member with factored axial compression load less than 0.10 times F plus C times G, the tensile strain A nominal strength shall not be less than 0.004. This makes sure the amount of tension steel to not more than 75% of the amount in the balanced strain condition, that is, max reinforcement ratio equals 0.75 times balanced reinforcement ratio. Typical interaction diagram. It is important to note that for the same cross-section there is an infinite number of strength combinations at which P and M act together. These strength of P and M combinations lie on a curve as shown in the next slide, which is called the strength interaction diagram. A interaction diagram. To generate the interaction diagram, it is always assumed that concrete compressive strain in the extreme fiber will be 0.003. A special condition in interaction diagram is balance condition. At this condition, the concrete compressive strain in the extreme fiber will be epsilon C equals 0.003 and the outmost reinforcement steel tension strength will be Fy, the yielding condition. In term of strain, it will be Fy divided by Es. Based on those assumptions, you can calculate the location of neutral axis.
Here are the steps to generate the interaction diagram for any shape of the reinforced concrete column. Step 1. Located the centroid axis. Please see attached figure. Step 2. Divided section into finite strips which will be parallel to neutral axis. The thickness of strip will be delta x. Step 3. Calculate XIC, XIS, and BI.
Typical cross-section. Step 4. Assuming location of neutral axis. Step 5. Assume epsilon C equals 0.003. Based on strain diagram, calculate epsilon IC and epsilon IS. Make sure concrete always in compression if in tension. Concrete strain will be equal 0 and steel will not exceed Fy. Step 6. By using stress-strain relationship, calculate stress in concrete and steel for each strip. Typical stress-strain relationship diagram. Step 7. Calculate forces and moments in concrete and steel for each strip. Step 8. Repeated each strip and summary all steps to obtain total forces P and moments M. Step 9. Calculate eccentricity E equals M divided by P. Now, you have 1 point on the interaction diagram. You can change the location of neutral axis by increasing or decreasing a small amount of distance, say delta d, and repeat step 5 to step 9 to generate next point on the interaction diagram. Of course, do not forget to calculate phi factor at each point on the interaction diagram. Most of interaction plot on phi times p divided by a g and phi times e and divided by a g times h, where h equals d in this presentation and a g is column cross-section area. In this computer program, the stress-strain relationship for steel is defined as strain equals stress divided by E, where the is Young's modulus. The stress-strain relationship for concrete is using Hubnested's stress-strain diagram, which can be found in section 15.2 of Reinforced Concrete Design by Z.K. Wang and Z.G. Salmon. The first example is a rectangular concrete column. After the cross-section, both output data and interaction diagram are also presented. The interaction diagram of this example is very close to published ACI interaction diagram. Cross-section. Interaction diagram. Output data. The second example is a L-shaped concrete column. 2 different cases are calculated to see which way is a more efficient design. After the cross-section, both output data and interaction diagram are also presented. L-shaped cross-section case A. L-shape interaction diagram case A. L-shape output data case A. L-shape cross-section case B. L-shape interaction diagram case B. L-shape output data case B. The third example is T-shaped concrete column. Again, the presentation is the same as L-shaped column. T-shaped cross-section case A. T-shape interaction diagram case A. T-shape output data case A. T-shape cross-section case B. T-shape interaction diagram case B. T-shape output data case B.
Need help? If you need help or have question regarding this presentation, you can contact us as shown in the last slide.